Okay, so imagine this for a second. You have a perfect living digital copy of a real ship. It's a model so accurate that it learns from every single voyage, and it can actually warn you about critical problems before they even happen. Now, this isn't science fiction anymore, this is the digital twin revolution.
And that's the big question, right? A perfect digital copy of something as insanely complex as a massive ocean-faring vessel? Well, the short answer is yes. And it's already changing absolutely everything.
All right, so let's get down to basics. What exactly is a digital twin? Because, there's a huge misconception out there, and we really need to clear that up right away.
This right here gets to the heart of it. So many people hear digital twin and they picture what's on the left, just a fancy, static 3D drawing. But that is not it at all. The reality is what you see on the right. It's a living, breathing, virtual replica.
And when I say living, I really mean it. This isn't some model that's just frozen in time. No, it is constantly being fed real data streams. So if the real vessel's engine starts vibrating just a little bit differently, the twin knows. If the hull starts to foul and create more drag, the twin notices it immediately. If the vessel changes, the twin changes with it, second by second. This is the perfect way to think about it. You've got your physical ship sailing the ocean, and then you have this invisible, data-perfect twin sailing right alongside it in the virtual world. And its only job is to give you insights you could never, ever get otherwise. Okay, so we get what it is, but how does it actually work? I mean, how do you take this massive steel ship and turn it into a predictive digital entity? Well, it all starts with data, and a modern ship is an absolute treasure trove of it. We're talking hundreds and hundreds of sources, from engine sensors and fuel meters measuring performance, to GPS and weather systems tracking conditions, and even maintenance logs that provide all that crucial historical context. All of this is literally the lifeblood of the twin. Then all that raw data gets put through this pretty amazing three-step process. First, it's all streamed into a secure digital environment. Then really sophisticated AI and physics-based models get to work, processing and simulating everything. And the result? You get a virtual ship that behaves exactly like the real one. And this right here, this is the magic trick. The digital twin isn't just a mirror of what's happening right now. Its real power, its real value, comes from looking into the future. By understanding exactly how the ship behaves in the present, it can accurately forecast what's going to happen next. Which brings us to the big so what question. Why does any of this matter? What's the practical value here? Well, it turns out this technology is the perfect answer to some of the biggest challenges the shipping industry is facing today. I mean, just look at what the industry is up against. You've got maintenance costs that are just spiraling, brand new super strict emissions targets from the IMO, machinery that's more complex than ever before, and this relentless demand for zero downtime. The old ways of operating, well, they just aren't cutting it anymore. This is where the twin completely changes the game. So the first major benefit is something called predictive maintenance. We're moving away from these rigid schedules, or worse, just waiting for things to break. With a digital twin, you can maintain exactly what is needed precisely when it's needed. Not too early, which is super wasteful, and definitely never too late, which can be catastrophic. And here are some real-world examples. Long before a critical bearing actually overheats and fails, its digital twin will have already detected the tiny, totally invisible vibration deviations that are screaming, "Trouble is coming." Before a fuel pump gives out, the twin sees those abnormal flow patterns. It's almost like having a superpower. The second huge benefit is all about optimization. By constantly simulating how factors like the ship's trim, its speed, and even the condition of its hull affect performance, the twin can pinpoint the absolute most efficient way to operate. And that saves both money and the environment. And the numbers here are just staggering. We're talking about an instant potential fuel savings of 3 to 10%. Now, for a large fleet, that translates into millions of dollars saved and a major, major improvement in their environmental compliance ratings. But the benefits, they don't even stop there. This technology also creates a permanent class-ready digital history for compliance. It provides a completely risk-free environment for crew training, and it helps manage those incredibly complex onboard energy systems. It's a total game changer across the board. So what's next? If this is what digital twins can do today, where is all this technology headed? Let's take a look at the future of shipping. You can really see the clear evolution of the check on this timeline. Right now, we're in the era of predictive maintenance. The twin gives you warnings. But very soon, we're going to move to prescriptive maintenance, where the twin doesn't just warn you, it actually recommends specific actions. And then, looking further ahead, we'll see fleet-scale twins, optimizing an entire company's fleet all at once. So the crucial takeaway here is this. This isn't just some nice-to-have technology. Just like AIS tracking systems or ECDIS became standard, digital twins are on a clear path to becoming mandatory. They provide a level of safety, efficiency, and verification that will soon just be considered essential.
The digital twin revolution is here. It's already making ships smarter, safer, and cleaner. And that really just leaves us with one final important question to think about. Is your fleet ready for its twin?